So I'm going to do part A and part D, because if you can do part A, you can do part B and part C. And by doing part A, it's going to be the same picture for part D. So that way I'm trying to save some time here and be as efficient in going through these problems as possible. So we do need a circle. So again, we're on vertical circles. So you make it look like that. And so yo-yo's twirled in a vertical circle of radius 0.7 meters. Some people put the radius on the picture. Sometimes I do. Most of the time I don't bother. As long as you have the forces on it, the yo-yo makes 3 revolutions per second. So what they were doing here, that number, the 3 revolutions per second, that's what it's going when I solve part A. But it's going to be a different one for that, because then I'm looking for the minimum. So at 3 revolutions per second, there actually will be a tension at the high point. So like I said, I'm going to solve part A and I'm going to solve part D, because that way the picture's not really going to change. So at the high point, I'm going to have the tension towards the center of the circle, and I'm going to have the weight towards the center of the circle. So labeling these, I'm going to have the weight and I'm going to have the tension. And so it says find the tension in the string at the highest point. Well, once we have the picture, I can describe it, summing up my centripetal forces, and I'm going to get both of them are towards the center of the circle. So the equation is going to be T plus W equals, now again, I can either say mv squared over r or mr omega squared. They're giving me revolutions per second, which isn't omega, but it's not radians per second. So again, if I have a choice, I'm going to solve it as mv squared over r. So that's how I would solve it. So the question is find the tension in the string. This is actually easier than the other one because the math is easier. If I want to solve for the tension, all I have to do is move the W to the other side. And since W is mg, I'm going to move it to the other side as mg because they didn't give me, oh, I'm sorry, they gave me the weight. So actually, I'm going to leave it as the weight. I'm just going to move it over. So that's going to be mv squared over r minus W. So there's a couple things I need to solve for because I do know what the R is. So I know what the R is, and I know what the I know what the W is, and I know what the R is. So I'm going to need to solve for M using the W, and I'm going to need to solve for V, knowing that the yo-yo makes 3 revolutions per second. So I have to do 2 things on the side, and then I'll have everything to plug into that equation. So I'll do it over here. The mass is W divided by G. So that's going to be 25 newtons divided by 9.8 meters per second squared. And what's 25 divided by 9.8? 2.55? 2.55 kilograms, all right? So that's one of the things we need. And then we also need the V. So the V, my starting point, is 3 revolutions per second. The yo-yo makes 3 revolutions per second, so that's my starting point, even though that is not a velocity. That's an angular velocity. But I can convert it into meters per second in one step. So I'm going to extend the line, and I'm going to go from revolutions to meters. 1 revolution, what distance do I travel when I do 1 revolution? 2 pi r. So 2 pi, and the radius is 0.7. And if you solve that, what do you get for that? What is it? 13.2? All right, 13.2 meters per second. Now the rest is plug in. So, do I have to bother with that? I'm trying to save time. Because the less time I spend on going over this, the more time you have to do these. So, if I get to a point where, it becomes just busy work, then I'll stop. Does that make sense? Because at this point, you've got all the numbers to plug in there, and you know what the answer is. The answer was what? 610 for part A? And look, the only difference between part A and part B and part C is in part B, instead of plus W, it would be minus W. So when you move it to the other side, it would be plus. So 610, and then you're going to add the W instead of subtract the W. So you're going to add 25 instead of subtract 25. That's a change of 50. So that means it's going to go from 610 to 660. And then at the halfway point, the weight's not even a centripetal force. So it's halfway between the answers for A and B. Okay, so